So let's pick up our overview of medical neuroscience by talking about the scope of the course. Now, the scope of the course is intended to reflect what we in the field of neuroscience consider to be the core concepts that every educated person interested in the field of neuroscience should wrestle with. And these core concepts have been defined and articulated by our professional organization called the Society for Neuroscience. The Society for Neuroscience has created one of the very best sources of authoritative information about the brain and the field of neuroscience at a website called brainfacts.org. So I would encourage you to visit there to complement your studies with me in medical neuroscience. These core concepts are beautifully laid out and illustrated on that website, and you can find them and read a bit more about them there. But essentially, medical neuroscience will cover these 8 core concepts. First, and perhaps most obvious to those of you who have an interest in the brain is indeed the body's most complex organ. And we will study that complexity in various ways and hopefully affirm that complexity. It's interesting to me that in recent years, the Society for Neuroscience has modified this core concept slightly. Perhaps we're being a little bit too parochial in our view of the brain, but we are now asserting that the brain is indeed the most complex structure in the known universe. And it's quite a challenge we have in front of us then to understand this organ and to wrestle with its complexity. Of course, we will never in our lifetime fully understand all of its mysteries, but I hope you'll be incredibly satisfied and even captivated by those principles and those organizational features that we will describe and that you will learn in your pursuit of medical neuroscience. Well, the next core concept maps into our second unit of knowledge in medical neuroscience, and that is that neurons communicate through both electrical and chemical signals. And we'll spend quite a bit of time talking about the generation of those electrical signals and how chemical messages mediate communication among neurons. We will describe the organization of neural circuits and talk about their genetic determination. And you'll see that genetically determined circuits are indeed the foundation of function in the nervous system. We'll talk about this wonderfully dynamic aspect of brain function that we call neuroplasticity. What we've learned over the course of my career in the field of neuroscience is that life experience can actually change the very structure and function of the nervous system. And you'll learn with me some of the principles by which that happens at the level of synaptic organization and circuit structure. As we move on to the later stages of the course, particularly in Unit 5 and 6, you'll learn that intelligence arises as the brain reasons, plans, and solves problems. So we will try to unpack for you some of those dimensions of cognition that are relevant for what we might call broadly intelligence, recognizing that even that word itself has multiple dimensions to it. The brain makes it possible to communicate knowledge through language. So as we explore the more complex brain functions in Unit 6, we'll spend some time talking about language processing and how the brain is organized to understand language and to make language in various forms. The 7th core concept is that the brain itself endows us with a natural curiosity to understand how the world works. Now, I can't state this core concept without reflecting on a student I had many, many years ago who came to me one day and said, I think we need to give up. And I said, what do you mean we have to give up? He said, I just don't think that the brain should be allowed to study itself. The liver doesn't get to do that. No other organ in the human body gets to do that, so why should the brain? Well, of course, he was being facetious. But there is a point there that the brain itself gives us the capacity to ask the kinds of questions that have brought us together in this global learning community that we call medical neuroscience. And we'll even touch on trying to develop an understanding of where does that curiosity come from. And then lastly, we'll talk quite a bit about primary discovery that have matured the field of neuroscience and expanded its boundaries. And thankfully, discoveries that have begun to have an impact in the real world and the lives of real individuals. So we'll talk about how fundamental discoveries in and around the world of neuroscience promote healthy living and new effective treatment for disease. And we're just getting started. I know some of you are here with me because you are afflicted with such diseases or your loved ones are addressing them. So I certainly want to be sensitive to those of you that come with very personal motivations for learning about medical neuroscience. And I hope that you'll engage with us through our discussion forums and share some of your stories with us as we pursue this particular core concept. Well, I've said quite a bit about these core concepts, and you'll see them repeatedly throughout our video lessons. I hope you won't get tired of them, because I truly do agree with those academic and thought leaders in the Society for Neuroscience that consider these to be the essential framework for all educated persons that are seeking to understand the structure and function of the human brain. Now, a bit more about the scope of the course. This content is organized into 6 units that will then unfold over a recommended 12-week course of study. We'll begin in Unit 1 in the first 2 weeks and survey the structure of the nervous system. So we call this aspect of our studies neuroanatomy. Unit 2 is concerned with neural signaling, and that includes the generation of electrical signals, the transmission of signals across synaptic junctions via chemical neurotransmitters, and the plasticity of those connections that come with patterns of use. So that's Unit 2, and that will occupy your studies in the 3rd and 4th weeks of the course. After Unit 2, we pivot to consider what we sometimes talk about as systems neuroscience, and this includes Unit 3, which is a survey of the sensory systems, and that will take you from weeks 5 to 7 in the course, and Unit 4, a series of studies focused on understanding movement and motor control. That will occupy your life in weeks 8 and 9 of medical neuroscience. Following the conclusion of those 2 systems neuroscience units, we shift gears a bit and consider how the brain came to be. So Unit 5 of the course is called the changing brain, which focuses on the development of the brain from embryogenesis all the way across the lifespan. And that leads us to the final unit of medical neuroscience, Unit 6, that will occupy your studies in the 11th and 12th weeks of the course. Here, we'll focus on the more complex aspects of brain function that pertain to the operation of much of this outer part of the cerebral hemispheres that we observe from the outside of the brain. And this is the cerebral cortex, and specifically the associational sectors of that cerebral cortex will be front and center as we consider the most complex aspects of brain function. Now, this is medical neuroscience, and my goal is to take you through those units of content with a particular focus, and that is to understand how this foundational knowledge in neuroscience relates to an understanding of the impact of neurological injury and disease. And one pedagogical method that we will use to address that framework is to use problem solving through the study of clinical cases. So here's how I'd like that to work for you. So the human brain, the human nervous system will be at the center of everything that we do. But as we pursue our studies, we will increasingly begin to introduce the neurological signs and symptoms that suggest a localized injury in the central nervous system. And we will use this iterative paradigm as a way of first learning the structure and function of the nervous system so that we can then predict what might go wrong given a set of neurological signs and symptoms that a real person would present with. And then as we move towards our final exam in the course, you'll see that we will increasingly lead with those neurological signs and symptoms and see if we can't deduce or localize a lesion in the central nervous system that would be consistent with what one would observe clinically through a neurological assessment of a real patient. So this process will unfold. We'll build upon this. We'll increasingly shift towards clinical case studies as the course progresses. And this is exactly the competency that professionals in the healthcare environment acquire as they understand the basic framework of the nervous system that allows them to be informed by what they observe in their patient interviews and in their physical assessments of their patients. Well, now that you know more about the scope of medical neuroscience, I'd like us to now turn our attention towards the resources that are available to you to support your learning.